Yeah. So phosphate. So easy when I was doing this. Or phosphate. Phosphate.
I think phosphate is O3. All right, so what did you decide for how many particles does one of these compounds give us? This one is 4, good. So let me pull up a paper. The first one is on the left is 4. So I know this because it's ionic. We have a metal and then a polyatomic ion. And then we have 3 sodium ions and 1 phosphate. Okay, so that's 3 plus 1, that's 4. Okay, how about the next one? How many is this going to give us? 2. We got potassium and chlorine. Okay, it's a metal and a nonmetal. If it's a metal and a nonmetal, when we add it to water, it will split into its ions. Okay, how about this one? Oh, you can't see? Sorry. Yeah, I can close it.
That did it. Thank you.
Thank you for telling me that. Oh, how many? This one is 2. Did we talk about that? I can't remember. 2. Great. How many does this one give us? Good. 1. This is a covalent compound. So it's not made of ions. Each molecule will just stay together in solution. How about this one? 3. Good. We got 2 potassiums and 1 sulfate. So that's 3. Okay, great. Next one, calculate the amount in grams of sodium chloride needed to be weighed out to make 0.25 molar sodium chloride. All right, so in the lab, you got 2 potassiums and 1 sulfate, so 3 ions. Okay, in the lab, you're going to make 2 solutions. You're going to make one that's made out of salt and one that's made out of sugar. And then you're going to fill some beakers with distilled water. So the first 2 pieces you need to do to make part C. And then part C takes a long time. It says wait at least an hour. So you're going to try to get through part A, part B, and part C really quick. And then part D also takes a long time. So we'll see how B-Day does tomorrow, and then we'll see if you each have to do the freezing point and melting point, or if we're going to split that up. We'll see. Okay, so the first one is we're taking enough salt to make a 0.25 molar solution. So molarity is moles of solute over liters of solution, of total solution. So this is going to be salt plus our water, okay? So in this instructions, it says 100 milliliter. We're using 100 milliliter volumetric flask. So this is a volumetric flask. Can you see that line? So you're going to put your salt in, and then you're going to fill up the water to the line. Then your total volume will be 100. That's including the salt volume and the water volume, because concentration is liters of total solution, not just solvent, total solution. Okay. So that's what you need to do for the first sample with salt. Okay. That tells us, let's see, where are we? That also tells us the volume that we're going to use here. So our volumetric flask is 100 milliliters. So the volume is 100 milliliters, which is the same as 0.1 liters. Okay. We have a concentration which is 0.25 molar. We're looking for the number of moles. We have this equation. Bless you. Number of moles is equal to concentration times volume. So this is from one of the chapters that we've talked about. Sorry, still on the same night. All right, so we're going to take C, which is 0.25 molar. Molarity is moles per liter, excuse me. So I'm going to change this unit to moles per liter. And then I'm going to multiply by the volume in liters. That's going to give me moles. So my liters is going to cancel out. Excuse me. And we got 0.25 times 0.1. That's the number of moles. Oh, 0.25 times by 0.1. So 0.025 moles of sodium chloride. Okay, our scales don't measure in moles. We have to convert this to grams. That's what we're looking for. How many grams of sodium chloride? How many moles? Or grams. How do we do that? We're going from moles to grams.
Molar.
Good. Multiply by the molar mass. So we need the molar mass for sodium chloride. So we can just add sodium and chloride. We're in a lab, so if you really had to do this in real life, you could just look it up on like the internet would tell you. Or we can add sodium and chlorine from our periodic table. So I can't see that far. And use this periodic table. My periodic table says sodium is 22.99 and chlorine is 35.45. So, or I could look this up. The internet will tell me the molar mass of sodium chloride. And I'm going to get 58.44. And this unit, the unit for molar mass is always grams for 1 mole. It's how many grams it takes to get to 1 mole for that compound. We have 0.025 moles. So if we multiply the molar mass and the number of moles, moles cancels out and we'll get grams of sodium chloride. Oh, I guess I could have kept that on my calculator. Molar mass times number of moles. I've got 1.461 grams of sodium chloride. Okay, how many sig figs should we show here? Yeah, good. This has 2, so we better show 2. So what should we round to?
1.5.
Yep, 1.5 grams. Nice, yeah. All right, so then you should go to your data sheet, wherever the data sheet is. It looks like this. It says, from the PreLab, what amount of grams of sodium chloride should be weighed out to make 0.5 molar sodium chloride? How much? 1.5. So you're going to write this in this box, okay? Then you're going to go in the lab, and you're going to actually do this. And it might be different. Like you might have weighed out 1.6 grams. So if you weigh out 1.6, you need to write that down, okay? If you weigh out 1.5, you're going to write 1.5 down. And then it says calculate the actual molar concentration. So you're going to do the backwards of what we just did. You're going to take the grams, convert to moles. Take moles divided by 0.1. So you have to do this box, even if you just weighed out 1.5 grams, okay? Next one. The second thing you're going to do is you are going to calculate how many grams of, we are using sugar. This is glucose. So we're going to use this equation. I think something like that. Because that's what ingredient we have. the whole lab said sugar, so I thought it meant sugar, but apparently the equation they're using is glucose. So next year I will buy glucose if that's what they want. But for this year, we're going to use table sugar, which has a chemical equation of something like this. Okay, so we are using little m. Little m is on the second page of our lab instructions. Little m is molality or molal, moles of solute over kilograms of solvent. So in the procedure, hopefully you will notice it says obtain 100 milliliter volumetric flask. Okay, you only have one, so you have to clean it out from the salt. So clean it out really good, and then you're gonna fill this whole thing with distilled water all the way to the line. So this one is different because you are dividing by the kilograms of solvent. You are using 0.1 liters of solvent. You're going to measure your solvent with this very accurate volumetric flask. Okay. Okay, so basically we're going to do the same thing. Molal is kilograms of solute over, moles of solute over kilograms of solvent. Okay. We are using 0.1 liters of water or solvent. So we need to convert that to kilograms. Okay, I forgot. So 100 milliliters is easier to convert. We have done this in the Alex topic. We did this. So the density of water is 1 gram for 1 milliliter. If I have 1 gram of water, that's 1 milliliter. So I'm going to divide, or the milliliters cancels out, and that's how we're going to get to grams. So if I have 100 milliliters of water, distilled water in my volumetric flask, that should be about 100 grams. Well, it should be. Okay. Then we need to convert to kilograms. So I'm going to divide by 1,000. So 1,000 grams for 1 kilogram. Grams cancels, and we'll get 0.1 kilograms of water. Oh. So that is the bottom value. We have this value. We are trying to make a 0.25 molal solution. So that way we can find moles of the sugar. Okay. So we'll put this 0.25 over here. And then we're going to say moles of solute or sugar. Our solute is sugar here. And then divide by 0.1 kilograms of water. So then we are going to solve for moles. So we're going to multiply both sides by 0.1 kilograms over here. Okay, and then this is just moles per kilogram. And units cancel out. Great, we're going to get the same number of moles. Interesting. Point 0.1 times 0.25 gives us same number, 0.025 moles. All right, but our solute is different. We need grams. How do we go from moles to grams? Molar mass. Multiplied by the molar mass. So 0.025 moles multiplied by the molar mass, which is somewhere. Let's find the internet. Molar mass of sugar. Okay. Great. Yes, we're just gonna use this value. You cannot do this on the test, but if it's an assignment or if it's a lab, you can just look it up. Because in real life, that's probably what you're gonna do. Or if you use sugar over and over, if you use this for a year, you'll probably memorize it. So depends on your situation. Okay, where were we? Here we are. Okay, so I have the molar mass. I looked that up. Moles cancels, and we're going to get grams. So 0.025 times 3, 42.2965. Okay, and that gives me 8.5574 grams of table sugar. Okay, how many sig figs should we use here? Okay, so what should our number be? Okay, grams of sugar. Great, so you are going to go to your data sheet. And the first box, oh, I don't know why there's a floating box there. The first box says, from the PreLab, which we're doing right now, what is the amount of grams of, oh, this should be sugar. Let's fix it. Sugar. Okay, that should be weighed out to make 0.25 molar. Oops, this is also supposed to be, that's okay. You can leave that, that's fine. We're using sugar, not glucose. I don't think it says, if you can find glucose in the lab, tell me. But otherwise, I think they just say sugar the whole time. So then I got confused that I was supposed to be using glucose. All right, great. So then you're gonna measure out how much sugar you actually used. So you should get about 8.6, write down what you actually weighed out. And then you're going to dump your solution into a foam cup, but you need the mass of the foam cup first, and then you're going to add the water, then you're going to measure it again, and they're trying to get you to see, is the density of water really 1? So if you measure the cup and the water should be about 100 grams. And that's what this is trying to get you to think about. Is the mass, or is the density of water actually 1? 100 grams over 100 milliliters. Okay, great. And then you're going to write here what your actual concentration is. So moles of sugar over kilograms of water. So you should use 0.1 kilograms of water, but however many moles of sugar you actually use is what you're going to use here to calculate. You should do calculations at the end after you're done with the lab. Don't waste your time in the lab, especially at the beginning, with doing calculations. So try to get through the lab and then come back and do calculations. All right, so then the next part is, part C. Let's do part 5, and then we'll talk more about the lab. So the last part is we can use these equations to predict the difference in temperature we should be expecting for the freezing and the boiling temperatures. We can also predict so this would be interesting, if you want your temperature difference to be a certain amount, like if you need a solution that freezes at -10, maybe you could figure out how much you need to add to water to drop the temperature that much. So that's what this question is asking. What would the concentration of a water and propanol solution if the freezing point was -2.72 Celsius? So we're going to use this equation. The change in temperature of the freezing point, I'm just getting this from my lab, is equal to the molality, or the concentration, times Kf times I. This is propanol. So it has an aldehyde. We're going to talk about that in chapter 12. Okay, so we're looking for M, the concentration. And we have Kf in my table here. Kf of water is 1.86. How many particles will this compound break into? This one. Yep, so I is 1. 1. We're looking for M. Tf. So what's the freezing point of water? You told me already.
30.
Yeah, 32 Fahrenheit, 0 Celsius. So if it goes down by 2.72, the difference is 2.72. Okay, so that one's easy. So we're just thinking like, what's the difference between where it should have been at 0. Now it's at 2.2 because we added this compound to water. All right, then we're going to solve for m. So I'm going to divide both sides by 1.8. M is whatever this is. 2.72 divided by 1.86. And that gives us 1.4623. All right, and how many sig figs should we keep? 3. Yep. So my answer will be, what should the concentration be? It should be 1.46 m. Okay. I want to point out that the post-lab questions, not all of them, a lot of the post-lab questions are like number 5. And a lot of them are things that you could just do before the lab. So if you have extra time for some reason, maybe during flex, you're like, oh, I'm so bored, you could do this post-lab, most of the questions. Because they're just calculations, okay? All right, so let's talk about the lab. So you're going to make your sugar solution in part A. Then you're going to make your salt solution part A, sugar solution part B. Then you're going to make little packets. So I'm going to show you how to do this, but you have some dialysis tubing. This is dialysis tubing, and then you're going to work with it and make it. Okay, so it starts like this. It starts as like a flat piece of paper. Then you have to fill it with water and get it to be soft. So let's do that. I'm gonna put it in. You're gonna use distilled water. I'm using tap water. And you have to get your finger in here and get it to be wet. Soak it. Oops, it doesn't want to go in there. Okay. And then you're gonna work with it and get it. It's like a kind of like a tube, and then you have to make like a candy wrapper out of it. So there's some floss. You're going to use the floss to tie the ends shut. So one end you're going to tie shut. The other end you're going to leave open. And you're going to fill 5 milliliters in one with salt, your salt solution. And the rest of the salt solution you're going to be put in a beaker. Then you're going to take your sugar solution and put 5 milliliters in a new one of these. So you have 4 of these. And then you're going to tie both ends shut. Make sure it doesn't leak. And then you're going to put 2 of these are going to have 5 milliliters of distilled water. And then you're going to tie them shut. So then you're going to put I think it tells us here. Oh, in the table. You're going to put the salt solution in a distilled water beaker. And you're going to take the sugar and put it in a different distilled water beaker. You're going to put one of the packets that has distilled water, you're going to put it in the rest of the salt solution. And then you're going to put another distilled water in the rest of the sugar solution. And then you're going to put some water in a beaker and there's a prune. You're going to put a prune in that one. Before you put them in the solution, you have to find the mass before and the mass after. So the point is, osmosis is going to change the mass. So do you remember how osmosis works? Okay, so it has to do with cells. Cells use that a lot. Osmosis means that things will go from a high concentration to a low concentration spontaneously. So this one, we would predict that this should increase in mass because you have distilled water. Maybe it'll go high concentration. Maybe it goes the other way. Anyways, it tries to get to equilibrium. So they're going to try to equal each other. Maybe it goes, yeah. So the low concentration is going to try to equal the high concentration. And this little papery stuff, this plastic, is called dialysis tubing. So it allows for diffusion of particles. So water is going to be able to move through this. So if this has salt water, the water can move through to try to make the concentrations equal between the two solutions. Okay, so we would expect these two to go up in mass. This one should go down in mass. That's what we're expecting. And then the prune should increase because it's dried out. So then you're putting in water. It should accept water. And that's what is going to take the longest. So what you're going to try to do is set all these beakers up and then wait for an hour. If you don't have an hour, then you'll have to come after school to weigh it. If you can't come after school, then you'll have to come on, you guys have this on Friday. Then you'll have to come on Monday during flex and weigh the samples. When you are weighing any of these, you need to make sure that you're using a weigh boat. I do not want you to be putting these, they might be a little bit damp. Do not put these, or the prune, do not put them directly on the scale. We never just directly weigh chemicals on the scale. You always have either a beaker or a weigh boat on there. So tear the weigh boat and then weigh the little packets of solution. Okay, so soak this in water for a minute, and then what you're going to do is you're going to try to get it to open. And it is kind of tricky, but you just have to believe that it's going to happen, and then it does. So I'm just moving my fingers back and forth. Ah, there it goes. So what you want is you want to be able to open it like a tube, kind of like a tube. This starts out as a cylinder. And so you're going to tie one end shut. And then the other end you can fill with liquid. I don't know if you can see that. Now it's kind of like more of a tube. It's still kind of sticky to itself. I would use the droppers. So I would try to get one end open and then fill it with your solution. It says 5 milliliters. You're taking the mass anyways. So get close to 5 milliliters and then tie it shut. It says not to put any air in there. If there's a little bubble, not a problem. Okay? So do this as fast as you can so that you can have some time for it to sit. So you don't have to come back and measure the mass. If you have to do that, that's fine though. Okay, that is the lab. The next part, I guess there's part D also. Part D also will take a while. You're going to take a 100 milliliter beaker and fill it with ice and then take the mass. So finding the mass of the ice. Then you're going to take the beaker and scoop 100 milliliters of salt. You're going to use rock salt. There's some rock salt at the center table. You're just going to get a scoop out of the bag. Let's see. And then you're going to add, so in the beaker, you're going to have 100 milliliters of water, 100 milliliters of ice, 100 milliliters of salt, and you're going to stir it. It tells you to stir with a thermometer. Do not stir with a thermometer. Stir with a stir rod. If you stir with a thermometer, it may break. I had somebody in my first year, they broke a thermometer by stirring with a thermometer. And then you have to start over because your solution is not just salt and water. We don't have mercury. We got rid of them. If you find a mercury thermometer, we need to get rid of it. We have alcohol thermometers, the red stuff. If you have a silvery thermometer, we're trying to get rid of those. So don't use those. And that would also be really bad if you broke that. So do not stir with your thermometer, stir with the glass stir rod, and then you can check the temperature. It says to wait for about 5 minutes, and then the temperature will stop changing, and that's the temperature, the new freezing point. It should be below 0. Then you're going to take that beaker with ice and water, and you're going to put it on a hot plate, and you're going to heat it until it boils. And that might take a long time. So if it's going to take too long, we can split into sections and like have some of us boil the water and some of us freeze the water. We'll see. I'm not sure. Okay, that's the lab. Questions on the lab? All right, great. So if you haven't already, turn in your PreLab.